where will this go next? So it turns out the formula that we've been using to find the derivative, the slope of the tangent line, that is a fantastic starting place. But we need to get a little bit more advanced in order to progress when we get to the next section in 2.8. So we're going to look at an equivalent formula for the derivative, an equivalent derivative formula. Okay, right now we've been working with this. So let's just go ahead and repeat that. F prime of a equals the limit as x approaches a, f of x minus f of a over x minus a. What are we going to do? So you might be thinking, why do we need a new formula? Well, it's just we're not going to see it until 2.8, but maybe we'll get kind of an idea of why it's important and how it connects with something else that we're familiar with. What we're going to do to get this new formula, we're going to introduce a new variable. We're going to call it h. We're going to let h equal that denominator, x minus a. All right, why are we doing this? Just go with it. Let h equal x minus a. We're going to rewrite this whole formula so that it does not have an x any longer, but it has an h. So the new formula will have a's and will have h's. Like, okay. So the denominator there will become h. Hey, if h equals x minus a, and we're going to get rid of the x's, what does x equal? If we were to isolate x here, what does x equal? You think, well, couldn't we add the a over there? And yep, absolutely. If h equals x minus a, then x will equal a plus h. Okay, all right, I guess so. So this a plus h is going to go up in this place to replace that x. All right. So we've replaced this whole thing. We've replaced that x. There's one x left. It's right here in the limit. Okay, so still think about this formula here. H equals x minus a. As x approaches a, what does h approach? We're going to fill that in. As x gets closer and closer to a, what is h getting closer to? If you think about this, what happens as these two get closer to one another? As x becomes closer to a. Well, if x is getting closer to a and we're subtracting, wouldn't h be getting closer to 0? Yes. The closer these two get to one another, that gets closer to 0. So our limit is now not going to be x approaching a, it's going to be h approaching 0. Okay, we're ready. Here's the new formula. F prime of a is equal to the limit as h approaches 0, f of a plus h minus f of a all over h. And there you go. Now, again, it's not clear like why this is such a big deal, but maybe you see something you recognize. When you look at this part of it, does that remind you of the difference quotient? Now, in the difference quotient, we've got x's, f of x plus h minus f of x all over h. But a is an x value. So, okay, this is kind of where it's going. All right, we're going to use, let's kind of keep that formula there on the screen. We're going to look back at those same examples we did just a moment ago, but now with our new formula. Okay, so we're going to compare we're going to try this out with some familiar examples. So let's look back to f of x equals x squared plus 2x minus 1 at a equals 3. But now we're going to do it in this style. So we'll begin by taking the value of a and just plugging that into all of the a's. And now there's only 3. 1, 2, 3. And how is it going to work? The algebra is going to be a little bit different, but we should get the same answer as before. So it's still f prime 3 equal to, now it's the limit as h approaches 0. And you kind of realize this is never going to change. It's always going to be the limit as h approaches 0. It's always h to 0. Okay. And then f of 3 plus h minus f of 3 all over h. Now, before we go any further, just kind of think about this with me for a moment. What if we tried to plug in 0 for the h's? What would happen? If we tried to plug the 0 in here, we'd have f of 3 minus f of 3. And if we plug the 0 in here, obviously it'd be 0. So plugging the h as 0 would still be 0 over 0. Okay, so we can kind of notice these sort of things. All right. Let's get rid of this. Where are we going to go next with the algebra? Let's compute both of these things in the numerator. Let's use our function now to figure out f of 3 plus h. So I've gone ahead and I got that. Sort of some work on the side, if you will. So f of 3 plus h, okay, that's 3 plus h squared plus 2 times 3 plus h minus 1. And I'm going to go ahead and multiply that out. 9, foiling this thing, 9 plus 6h plus h squared. And then plus 6 plus 2h minus 1. We can combine like terms here and get it all the way down to h squared plus 8h. And then all those constants would be 14 plus 14. Just kind of working that out on the side before I put it into my new derivative formula. Maybe at the same time, what's f of 3? Well, I think we did this back in the last example. That's all right. F of 3, plugging 3 in, well, we get 14. Okay. So let's put these parts in to our formula, and I'll just kind of go ahead and slide all this up here. F prime 3 equals the limit as h approaches 0, h squared plus 8h plus 14 minus 14. All over h. Okay. And once we get this far, we're really just thinking, are we going to be able to perform this limit? And yeah, this is great. It's so much simpler, at least once we're at this point. Well, because obviously the 14s cancel. Leaving just this, we can then factor out an h. All right. F prime of 3 equals the limit as h approaches 0, h times h plus 8 over h. Of course, those h's cancel out. And then let's just go ahead and plug the 0 in. And what do you know? Oh, looks like I wrote that line. Plugging in the 0, we get the same answer as before. F prime 3 equals 8. That's a good thing. We wanted to get the same answer. We were hoping we'd get the same answer. Now, once we've done this this example for a second time with this other formula, no one is trying to argue that this new formula is easier than the previous formula. Truth is, most folks find that this new formula is more work than the previous formula, right? The previous one, all we had to do was factor and then boom, boom, and we had it. Here we had to FOIL this stuff, and And it's not that it was harder, but it was more steps. No one's saying that this is an easier formula, but we do need it for how we're going to advance very soon. Okay. Let's try out that other example. One more time, just to see how this one would unfold. F of x equals square root x, a equals 25. All right, what's that going to look like with the new formula? Here it is to get started. F prime 25 equals the limit still as h approaches 0. F of 25 plus h, again, we put the 25 right there, minus f of 25. Oh, gosh, shadows. Minus f of 25 all over h. Okay. Well, what should we do? There's not a whole lot to do here. We're just going to kind of keep moving along. There's no like work on the side we need. F of 25 plus h, well, we're just going to put that right in there into that square root. And f of 25, well, you know, we can see that that's going to be 5. All right. Once we have this in place, well, we just got to, can we figure out what this limit is? And, well, hey, it's another conjugate. So when we did it in the other style, it was a conjugate as well. That part doesn't change, just the details. So we'll multiply the top and bottom by the conjugate of that numerator. Okay. And here's the next line. So we multiply, we start to FOIL, square root right there, right? Middle terms cancel, and then minus 25. The denominator, well, don't actually distribute, just keep it as h times the quantity square root 25 plus h plus 5. Okay. And then once you get to here, well, I would say once you get to this point, maybe it is easier because, of course, those 25s cancel out. Then the h reduces, and all we have is a 1 there on top. So f prime 25 equals the limit as h approaches 0, 1 over square root 25 plus h plus 5. And finally, now we can plug the 0 in for h. What's that going to give us? Well, square root of 25 plus 5. When we plug it in, f prime 25 equals 1 over 10. We got the same answer as before. Very nice. Okay, pretty exciting. Let's stop this video here. I've got one more, an application problem in the next video.